In this section, we're going to look at control flow, or controlling the flow of execution of our programs. We're going to start off by talking about comparison operators for comparing values. Then we're going to talk about logical operators like the logical AND, logical OR, and logical NOT. We use these operators for implementing real-world rules. And then we're going to talk about 3 different types of control flow statements. We're going to talk about conditional statements for making decisions in our programs. Then we're going to talk about loops for executing code repeatedly. And finally, we're going to revisit our mortgage calculator and add error handling to it. So if the user enters an invalid value, we keep asking them to try again. All right, now let's jump in and get started. About variables in Java. We use variables to temporarily store data in computer's memory. Here's an example. Imagine in this program, you want to store someone's age in the memory. So we declare a variable like this: int age equals 30. So int, or integer, is the type of this variable. So in this variable, we can only store integers, which are whole numbers, like 1, 2, 3, 4, numbers that don't have a decimal point. Now in Java, we have several different types. I'm going to talk about them in the next tutorial. So first, we specify the type of our variable. Then we give it a name or a label. This is also called an identifier because we use it to identify our variable. This equal sign is called the assignment operator, and 30 is the initial value that we are assigning to this variable. So we say on line 6, we're initializing this variable, which means we're giving it an initial value. We always have to initialize our variables before reading them. So with this line, we're storing number 30 somewhere in computer's memory, and we're assigning this label to that memory location. Now on line 7, instead of printing hello world, we can print the value of the age variable. Take a look. So I'm going to run this program using Control and R. There you go. Now we see 30 on the terminal. Beautiful. We can also change the value of our variable. So after we initialize it, perhaps we can change it to 35. Now when we run this program again, we see 35. Beautiful. We can also initialize multiple variables on the same line, but this is something that I don't recommend because it makes your code ugly and hard to read. Here is an example. We can declare another variable like temperature and set it to 20. So using a comma, we can declare multiple variables on the same line. Now, even though this is technically possible, it's not something that I recommend. So it's always better to declare one variable on each line like this. We can also copy the value of one variable into another. Here is an example. Let me delete these variables and declare a new variable called my age. We set it to 30. And then we declare another variable like her age, and we set it to my age. So now when we print her age, we're going to see 30. Take a look. So on line 7, we're copying the value of this variable into this other variable. Now, one thing I want you to pay attention to here is the convention I have used for naming our variables. As I told you before, this is called the camel case notation. So we should capitalize the first letter of every word except the first word. So in this case, the first word, my, it's all in lowercase, but the second word starts with a capital letter. So this is all about declaring and initializing variables. In the next tutorial, we're going to talk about various types in Java. Various types in Java. Basically, we have 2 categories of types. We have primitive types for storing simple values and non-primitive types or reference types for storing complex objects. So in the category of primitive types, we have byte, which takes 1 byte of memory. And in 1 byte, we can store values from 128 to 127. Now, the more bytes we have, the larger numbers we can store. So next we have short, which takes 2 bytes. And with this, we can store values up to 32,000. Next, we have integer, which we have seen before. Integers take 4 bytes of memory and allow us to store values up to 2 billion. Then we have long, which takes 8 bytes. And with this, we can store even larger numbers. Now, all these types are for storing whole numbers that don't have a decimal point. If you want to store a number that has a decimal point, you have to use float or double. Float takes 4 bytes, double takes 8 bytes. So obviously with double, we can store larger numbers. Next, we have char for storing a single character like A, B, C. And these char types take 2 bytes. so they support international letters. And finally, we have Boolean for storing Boolean values, which can be true or false, just like yes or no in English. Now let's take a look at a few examples. Earlier, we used an integer for storing someone's age, but as you learned, integers take 4 bytes and allow us to store values up to 2 billion. We don't need 4 bytes of memory to store someone's age. All we need is 1 byte, because with 1 byte, we can store values up to 127. So I'm going to change this to byte. That is better. Now let's look at another example. Let's say we want to store the number of times a YouTube video has been watched. So we define an integer called views count. Note that I'm always using meaningful names for my variables because these names help us understand what this code does. I've seen some people use variable names like v or v1 or n. Nobody knows what these variables do. So as a best practice, always use meaningful and descriptive names for your variables. So views count, we set this to a large number like 1, 2, 3, 4, 5, 6, 7, 8, 9. Now in Java, whenever you deal with a large number like this, you can use an underscore to separate every 3 digits, just like how we use a comma in our documents to make our numbers more readable. We can use an underscore in Java. So with integers, we can store values up to 2 billion. But let's say the number of times this video has been watched is 3 billion. So I added 3 here. Now we have a red underline that indicates an error. When we hover our mouse over it, we see this tooltip, integer number too large. So we need to change the type of this variable to long. However, the error is still there. What's going on here? The reason we're getting this error is that by default, Java sees these numbers as integers. So even though we have defined the type of this variable as long, Java compiler sees this value as an integer, and it thinks this value is too large for an integer. To solve this problem, we need to add an L as a suffix to this number. We can use an uppercase or a lowercase l. But as you can see, a lowercase l kind of looks like a 1, so it's better to use a capital L. So these are examples of whole numbers. Now let's declare a variable for storing a number with a decimal point. So double price, we set this to 10.99. Obviously, the double variable is too large for storing the price of a product, so we can change this to float. That is better, but we have a compilation error here. Take a look. Incompatible types, required float, but found double. The reason we're seeing this error is that by default, Java sees these numbers with a decimal point as double. So even though we set the type of this variable to float, Java sees this number as a double. So just like how we added a suffix to this number to represent it as a long, we need to add a suffix here to represent this number as a float. And that suffix is f. Once again, we can use an uppercase or lowercase f. So these are examples of numbers. Now let's store a character. So char, we call it letter, and we set it to A. Note that we should always surround single characters with single quotes and multiple characters or strings with double quotes, okay? So char represents only one character, string represents a series of characters. And finally, let's see an example of a Boolean. So we define a Boolean variable called is eligible. Is this person eligible for loan or not? We set this to true or false. These are the Boolean values. Now note that all these words coded in orange are reserved keywords in Java, just like public, static, void, class, package. These are all reserved keywords. So we cannot use these reserved keywords to name our variables, classes, and methods. And we use primitive types to store simple values like numbers, Boolean values, or single characters. In contrast, we use reference types to store complex objects like data objects or mail messages. These are complex objects. Now in Java, we have 8 primitive types that you have seen before. All the other types are reference types. Let me show you an example. So here in this program, first I'm going to declare a primitive type. Let's say byte age equals 30. Now, declaring and initializing a reference type is slightly different from a primitive type. Let me show you. So let's type date. Now here in this tooltip box, which is called IntelliSense, we can see various classes that have date in their name. So IntelliJ is helping us complete our code by suggesting these class names. Now here we have a date class in this package, java.util. So this package contains a lot of utility classes that are useful in a lot of programs. We also have a date class in a different package, java.sql or SQL, which is used for programming databases. So this is the benefit of packages. We can have the same class, but in different packages. They don't conflict. So packages create a namespace for our classes, okay? Now, in this case, if we select the first date class and press enter or tab, IntelliJ automatically adds this line for us. Import java.util.date. So because currently we are in this package, in order to use a class from a different package, we need to import it. So here we're importing the date class in this package. We'll talk about packages in more detail in the future. So back to our date variable. Let's give this variable a name, like now. Now we set this. Here we need to use the new operator to allocate memory for this variable. And this is one of the differences between the primitive and reference types. When declaring primitive types, we don't need to allocate memory. Memory is allocated and released by Java runtime environment. But when dealing with reference types, we should always allocate memory. Now we don't have to release this memory. Java runtime environment will automatically take care of that. So we use the new operator and then repeat the name of our class, in this case date, and then we add parentheses, followed by a semicolon. In this example, this variable we have defined here is an instance of the date class. So this classes define templates or blueprints for creating new objects, new instances. As another example, we can have a class called human, and we can have objects like John, Bob, Mary, and so on. So an object is an instance of a class. Now, these objects or these classes have members that we can access using the dot operator. So we can type now dot, and these are all the members defined in this class or in this object. For example, we have a method called getTime, and this returns the time component of this object. This is another difference between primitive types and reference types. These primitive types don't have members. So if you type age dot, we don't see anything. These items you see here are not members of age. They're code snippets which allow us to quickly generate code. For example, we can select for I, and this automatically generates this block of code for us. We'll talk about this in the future. So this age variable is a primitive type. It's not an object. It doesn't have any members. And that's why when we use the dot operator, we don't see anything here. Now let's delete this line and instead print the value of this data object. So once again, we can type system. This is a class, so we can use the dot operator to access its members. Here we have out, which is a field. And the type of this field is print string, which is another class in Java. So once again, we can use the dot operator and call the print line function. Now let me show you a very cool shortcut. Instead of typing all this, we can use one of these code snippets. So we type SOUT and press tab, and this generates this piece of code for us. All right, now let's pass our data object here. Note that I have not surrounded this variable with double quotes because this is a string. And if we run this program, we'll see now on the terminal. There you go. We don't want this. We want the value of our data object, not a label. So let's remove the quotes and run the program again. So here's the current date time on my machine. Differences between the primitive and reference types. So you know that we use primitive types for storing simple values and reference types for storing complex objects. But there is a very important difference between these two categories of types in terms of memory management. And that's what we're going to talk about in this tutorial. So I'm going to declare a primitive variable, x, and set it to 1. And then I'm going to declare another variable like y and set it to x. So in this example, we have two different variables, x and y, and these two variables are at different memory locations. So they're completely independent of each other. In other words, if I change the value of x, y is not going to get affected. Let me show you. So I'm going to update x to 2 and then print y. So SOUT tab y. Let's take a look. So run. As you can see, y is not affected because x and y are completely independent of each other. However, when we use a reference type, this behavior is different. Let's take a look. So I'm going to delete all the code here. In Java, we have a point class that is defined in this package, java.awt. So we press enter, and now we have this import statement on the top. Beautiful. Let's declare a variable like point1 and set it to new point. Here we can pass the initial values for x and y. So I'm going to pass 1 and 1. So IntelliJ automatically adds these labels, x and y. Now, just like before, I'm going to declare another variable, point2, and set it to point1. And this is where things get interesting. When Java runtime environment executes line 8, first it's going to allocate some memory to store this point object. Let's say the address of that memory location is 100. Then it's going to allocate a separate part of the memory, and it's going to attach this label to that memory location, point1. In that memory location, it's going to store the address of our point object. So this is the critical difference between primitive and reference types. When we declare a primitive variable like a byte, the value that we assign to that variable will be stored in that memory location. But when we use a reference type, like this point class, our variable is going to hold the address of that point object in memory, not the actual point object. Now look at line 9. Here we're copying the value that we have in this variable into this other variable. So that value, as you learn, is not the point object, is the address or the reference to the point object in memory. That is why we refer to these types as reference types, because they don't store the actual values, they store a reference to an object somewhere in the memory. So in this example, point1 and point2 are referencing the exact same point object in memory. We only have one point object. So these two variables are not independent of each other. They're referencing the same object. And that means if I update this point object through either of these variables, the changes will be visible to the other variable. Let me show you. So using the first variable, point1, we're going to update the value of x. So we use the dot operator, and here we can see the members of this object. X and y are both fields, which are variables that exist inside of a class. So we set x just like a regular variable to a different value. Let's say 2. Now, because point1 and point2 are referencing the exact same object, if we print point2, we're going to see the change that we just made. Take a look. So SOUT, tab, let's print point2 and run the program. There you go. So the change was visible. So remember this. Reference types are copied by their references, whereas primitive types are copied by their value. And these values are completely independent of each other. Strings in Java. So earlier in the course, we printed the hello world message on the terminal. This hello world that we have here is a string, or more accurately, it's a string literal. That means a string value. Now let's extract this from here and store it in a string variable. So cut. Just before this line, we type string. Now look, this string class is defined in java.lang package. What is interesting is that we don't have an import statement to import this package or import this class because this package is automatically imported. So we can use any classes that are defined in this package. Now let's declare a variable called message. And because this is a reference type, we should instantiate this variable using the new operator. So new string, and here in parentheses, we type our message, hello world. However, here we have this little warning. Take a look. New string is redundant because in Java, there is a shorter way to initialize string variables. Let me show you. So instead of using the new operator, we simply set this to our string literal. Now on the surface, this looks like a primitive type because we are not using the new operator, but this is just a shorthand to initialize a string variable. Strings are reference types in Java, but because we use them often, there is a short way to create them. So now let's pass message to the println method and run our program. We get the exact same result as before. Beautiful. Now let's look at a few interesting things that you can do with strings. We can concatenate or join a string with another one using the plus operator. So here we can combine this with another string with 2 exclamation marks. And here's the result. Now, because string is a class, it has members that we can access using the dot operator. So we can type message dot, and these are all the methods or functions defined in the string class. For example, we have this method here, ends with, and with this, we can check to see if our string ends with a character or sequence of characters. For example, here we can pass a string to see if our message ends with 2 exclamation marks. Now, instead of printing the message, let's print this expression here. So let's run the program. We get true. So this method that we have called here returns a Boolean value, which can be true or false. We also have another method, starts with. Let's take a look. Now in this case, we get false because our message doesn't start with 2 exclamation marks. Another useful method is length. So we can call that to get the length of a string, which is the number of characters. So message.length, take a look. So in this string, we have 13 characters. And this is useful in situations where you want to check the length of the input by the user. For example, you might have a sign-up form with a username field. You can check the length of someone's username and give them an error if the username is longer than, let's say, 20 characters. Pretty useful. We also have another method that is index of, and this returns the index of the first occurrence of the character or the string that we pass here. For example, if we pass h, the index of h is 0. So let's run the program. There you go, we get 0. If we pass e, we get 1 because the index of the first e in this message is 1. Now, what if we pass a character or a string that doesn't exist in this message? Let's say sky. We get -1. So with this method, we can check to see if a string contains certain characters or words or sentences and so on. Another useful method is replace. And with this, we can replace one or more characters with something else. For example, we can replace any exclamation marks with, let's say, a star. So this replace method has 2 parameters. One is target, the other is replacement. And here we're passing 2 values for these parameters. Here's the first value, here's the second value, and we have separated these values using a comma. Now in programming terms, we refer to these values as arguments. A lot of programmers don't know the difference between parameters and arguments. Parameters are the holes that we define in our methods. Arguments are the actual values that we pass to these methods. So in this case, target and replacement are parameters, but exclamation mark and asterisk are arguments. Now let's run this program and see what happens. So our exclamation marks are replaced with stars. Now what is important here is that this method does not modify our original string. It returns a new string. So if we print our original string right after SRUT, tab, message, you can see the original string is not changed because in Java, strings are immutable. We cannot mutate them. We cannot change them. So any methods that modify a string will always return a new string object. Okay? We also have another useful method, toLowercase. Let's take a look. So toLowercase converts all characters to lowercase. And once again, you can see that the original string is not affected because this method returns a new string. Okay? We also have toUppercase. And another useful method is trim. And with this, we can get rid of extra white spaces that can be at the beginning or the end of a string. Sometimes our users type unnecessary spaces in form fields. So using the trim method, we can get rid of these white spaces. Let me show you. So I'm going to add a couple of spaces before and after our message. Now, when we trim it, these white spaces are going to get removed. Take a look. So here's the original string. You can see 2 white spaces at the beginning, and here's our string after trimming. So these are some useful methods in the string class, but this class has more methods that we don't have time to cover in this lecture. But as we go through the course, you're going to learn more about the string class and other useful classes in Java. Special characters in our strings, like a tab or a new line or a backslash or double quotes. So in this tutorial, I'm going to show you how to include these special characters in your strings. So here we have the string, hello Mosh. Let's say we want to surround Mosh with double quotes. Now here's the problem. If we add a double quote here, Java compiler thinks this is the termination of our string, so it doesn't understand what we have after. That's why we have a compilation error. To fix this problem, we need to prefix this double quote with a backslash. So using this backslash, we have escaped the double quote. Now, one more time, let's add backslash double quote here. Now let's run the program and see what we get. So we get hello Mosh in double quotes. Beautiful. So double quote is one of those special characters that you need to be aware of. Another special character is backslash. Let's say we want to store the path to a directory on a Windows machine. So that will look like this. C drive, backslash, Windows, backslash, whatever. Now, if you want to store this in a string, we need to escape each backslash. Let me show you. So C drive, backslash. Now we have a problem. Java compiler thinks we're escaping the double quote here, so it thinks our string is not terminated with another double quote. But that's not what we want. You want to add a backslash here. So we need to prefix our backslash with another backslash. Now we type Windows, one more time, something. Let's run the program. So even though we have two backslashes in our code, we actually see one backslash in the terminal window. Another escape sequence is \n, and we use that to add a new line to our strings. So let's change this to \n and run the program to see what happens. Now our string is broken down onto multiple lines. On the first line, we have C drive, then we have Windows. So wherever we add a \n, Java will insert a new line. We can also add a tab in our strings. So if we add \t here, there will be a tab between C drive and Windows. Let's take a look. So C drive, here we have a tab, and then Windows. Now in Java, we have a few more escape sequences, but quite honestly, they're hardly used. So remember these 4 escape sequences that we covered in this tutorial. About arrays in Java. We use arrays to store a list of items, like a list of numbers, or a list of people, or a list of messages. Let me show you. So here we have an integer variable. We want to convert this to an integer array. So right after int, we add square brackets. Now we have a compilation error because we're storing a single number in this array. So to fix this, we need to remove 1. Because arrays are reference types, we need to use the new operator here. Then we repeat the type one more time, int array. And here in square brackets, we specify the size or the length of this array. How many items do we want to include in this array? Let's say 5. Also, we should change the name of this variable from number to numbers because we're dealing with a list of items. So always pay attention to the name of your variables. Now, we can access individual items in this array using an index. So we type numbers, square brackets. To reference the first element or first item, we use 0. Now we can set this to a value like 1. Similarly, we can set the second item to 2. Now, what if we use an invalid index? Let's say 10. This array doesn't have 10 items. So let's see what happens. Numbers of 10, we set this to 3. When we run this program, we get an exception. Exceptions are Java's way to report errors. So in this case, an exception was raised and our program crashed. We'll talk about exceptions in detail later in the course. So now let's remove the last line and print this array. So SOUT tab numbers. Let's see what we get. We get this weird string instead of the items in our array. Here's the reason. By default, when we print an array, Java returns the string, which is calculated based on the address of this object in memory. So if you have another array and we print that, we're going to see something different because each object is going to be in a different memory space, okay? Now, how can we see the actual items in this array? Well, We have a class in Java called arrays. Let me show you. Arrays. So this class is defined in java.util package. Let's press enter. Now, this is imported on the top. Beautiful. So we can use the dot operator to access the members of this class. Here we have a method called toString. Now, as you see, this method is implemented multiple times. So in the first implementation, this method gets a float array. In the second implementation, it takes an integer array, and so on. So for all primitive types as well as reference types, this method is implemented multiple times. This is what we call method overloading. Now, we can call this method and pass our integer array, and this will return the string representation of this array. So we can cut this from here and pass it to our print method, like this. Now, let's run the program one more time, and here's our array. Beautiful. So the first two items are initialized. The others are set to 0 by default, because here we're dealing with an integer array. If we had a Boolean array, all items by default get initialized to false. If you have a string array, all items get initialized to an empty string. Okay. Now, this syntax for creating and initializing an array is a little bit tedious, and it's an older syntax. There is a newer way to initialize an array if we know the items ahead of time, like in this case. So I'm going to remove these two lines. I'm also going to remove the new operator. Here we use curly braces, and inside these braces, we add all the items in this array. Let's say 2, 3, 5, 1, and 4. Now we have 5 items, so the length of this array is going to be 5. We can read that using the length field. So if we type numbers dot, look here we have this field. Look at the icon, it's an F. So this is a field which is like a variable in a class, and the type of this field is an integer. So this returns the number of items in this array. Let's get that and print it using our print method, like this. Take a look. So we get 5. Now in Java, arrays have a fixed size. So once we create them, we cannot add or remove additional items to them. They have a fixed length. If you want to be able to add or remove additional items from an array, you should use one of the collection classes that we'll talk about later in the course. For now, all I want you to remember is that arrays have a fixed length. Now currently our array is not sorted. These numbers are in some kind of random order. We can easily sort this array using the sort method of the arrays class. Let me show you. So I'm going to remove this line and call arrays.sort. Once again, you can see this method is overloaded because it's implemented with different parameter types. So we call this method and pass our numbers array. Now, when we run this program, we can see our array is sorted. Beautiful. It's to store a list of objects. In Java, we can also create multi-dimensional arrays. For example, we can create a 2-dimensional array to store a matrix, or we can create a 3-dimensional array to store data for a cube. These are useful in scientific computations. Let me show you. So here we have a single-dimensional array. To convert this to a 2-dimensional array, we need to add another pair of square brackets. Now we have a compilation error because we need to repeat these brackets on the other side. So let's say we want to create a 2x3 matrix. So 2 rows and 3 columns. We add another brackets here and change these lengths to 2 and 3. So now we have 2 rows and 3 columns. Now to access individual items in this array, we need to supply 2 indexes. First, the index of the row. So we can go to the first row and then the first column and initialize that to 1. Now let's print this. So SOUT tab. Once again, we use our arrays class dot toString and pass this object. Take a look. Once again, we get this weird string because here we're dealing with a multi-dimensional array. To solve this problem, we need to use another method in this class called deep toString. We use this for printing multi-dimensional arrays. Take a look. Now we have this matrix which has 2 rows, and in each row we have 3 columns. We can also create a 3-dimensional array. All we have to do is to add another pair of brackets and specify the length of that dimension. Pretty easy. Now, what about the curly brace syntax? Let me show you. So Let's revert this back to a two-dimensional array. We're going to get rid of the new operator and use curly braces. Now, let's say in this matrix, we're going to have 2 rows and 3 columns. So each row is an array itself because it's a list of items, right? So we add another array here. Let's say 1, 2, 3, then comma. Now we add the second row, which is another array. In this row, we're going to have 3 numbers, 4, 5, and 6. Now let's remove this line. We don't need it anymore. And print this array. So here's the end result. You have learned that when declaring them, we need to initialize them, and we can always change their value later on throughout the lifetime of our programs. However, there are times that we don't want the value of a variable to change. For example, let's declare a variable called pi and set it to 3.14. Now here we need to add an f to represent this as a float because by default, Java compiler sees this number as a decimal, okay? Now, you know that we use pi to calculate the area of a circle. What if before we calculate the area of a circle, I come here and type pi equals 1? Then all our calculations are going to get messed up. We don't want this to happen. That's when we use constants. So if we type final here, Java compiler will treat this as a constant. So once we initialize this, we cannot change its value later on. You can see here we have a compilation error, and it says cannot assign a value to final variable pi. So pi is a final variable or a constant. Now by convention, we use all capital letters to name constants. So this should be pi. Beautiful. Now I tell you a little side story. In one of my early courses that I created years ago, that was C# Basics for Beginners. There I used the same example to teach the concept of constants, but I pronounced this word as p instead of pi. And believe it or not, to this day, people make fun of me for saying p instead of pi. But that's how we learned this back in Iran. We pronounce it as p, and I think Greek people also say p. But anyway, I just thought to share this video to change the mood. Now we're done with constants. Next, we're going to talk about arithmetic expressions. Arithmetic expressions in Java. So in Java, we have the same arithmetic operators that we have in math. We have addition, subtraction, multiplication, division, and modulus, which is the remainder of a division. Let's look at a few examples. So I'm going to declare an integer called result. And here we can type 10 plus 3. Now when we print result, it's going to be 13. Pretty straightforward. There you go. So this is addition. We also have subtraction, multiplication. Division is an interesting one. Let's take a look. So here the result is a whole number because in Java, the division of 2 whole numbers is a whole number. If you want to get a floating point number here, you need to convert these numbers to a float or a double. Let me show you. So we prefix this number with parentheses, and in parentheses we type double. Now we are casting or converting this number to a double. Similarly, we should do that here. And now we have a compilation error because on the left side, we declared an integer, but here the result of this expression is a double. And by the way, an expression is a piece of code that produces a value. So what we have here is an expression because it produces a value. So to fix this problem, we need to change this to double. Now when we run this program, we get this floating point number. Beautiful. So these are the arithmetic operators. And these numbers that we have here are called operands. We also have increment and decrement operators. Let me show you. So I'm going to declare a new variable, int x, we set it to 1. Now, if you want to increase the value of x by 1, we use the increment operator. Now let's print this on a terminal. So we get 2. There you go. We can apply this operator as a postfix or as a prefix, and we get the same result. Take a look, 2. However, if we use this on the right side of an assignment operator, we get different results. Let me show you. So I'm going to declare another variable, y. We set it to x plus plus. In this case, because we have applied the increment operator as a postfix, first the value of x will get copied to y, so y will be 1, and then x will be incremented by 1. So if we print x and y, x is going to be 2, and y is going to be 1. Take a look. So x is 2 and y is 1. Beautiful. However, if we apply this as a prefix, first, x will be incremented by 1, so it will be 2, and then it will be copied to y. So in this case, both x and y will be 2. Take a look. So we get 2 and 2. Now, what if you want to increment x by more than 1? Let's say by 2. Well, there are 2 ways to do this. Let's remove y. We don't really need it anymore. We can write x equals x plus 2. So first, we add 2 to x. The result would be 3, and then 3 will be copied into x. The other way is to use the augmented or compound assignment operator. So we can write x plus equals 2. What we have on line 8 is exactly identical to what we have on line 7. But as you can see, it's shorter. So this is a better way to write the same code. Now, this is one of the augmented assignment operators. We have the augmented assignment operator for other arithmetic operators. So we can type x minus equals 2, and this will reduce the value of x by 2. We also have multiply and divide. So these are the augmented or compound assignment operators. Arithmetic expressions in Java. So in Java, we have the same arithmetic operators that we have in math. We have addition, subtraction, multiplication, division, and modulus, which is the remainder of a division. Let's look at a few examples. So I'm going to declare an integer called result. And here we can type 10 plus 3. Now when we print result, it's going to be 13. Pretty straightforward. There you go. So this is addition. We also have subtraction, multiplication. Division is an interesting one. Let's take a look. So here the result is a whole number, because in Java, the division of 2 whole numbers is a whole number. If you want to get a floating point number here, you need to convert these numbers to a float or a double. Let me show you. So we prefix this number with parentheses, and in parentheses we type double. Now we are casting or converting this number to a double. Similarly, we should do that here. And now we have a compilation error because on the left side, we declared an integer, but here the result of this expression is a double. And by the way, an expression is a piece of code that produces a value. So what we have here is an expression because it produces a value. So to fix this problem, we need to change this to double. Now when we run this program, we get this floating point number. Beautiful. So these are the arithmetic operators. And these numbers that we have here are called operands. We also have increment and decrement operators. Let me show you. So I'm going to declare a new variable, int x, we set it to 1. Now, if you want to increase the value of x by 1, we use the increment operator. Now, let's print this on a terminal. So we get 2. There you go. We can apply this operator as a postfix or as a prefix, and we get the same result. Take a look, 2. However, if we use this on the right side of an assignment operator, we get different results. Let me show you. So I'm going to declare another variable, y. We set it to x plus plus. In this case, because we have applied the increment operator as a postfix, first the value of x will get copied to y, so y will be 1, and then x will be incremented by 1. So if we print x and y, x is going to be 2, and y is going to be 1. Take a look. So x is 2 and y is 1. Beautiful. However, if we apply this as a prefix, first, x will be incremented by 1, so it will be 2, and then it will be copied to y. So in this case, both x and y will be 2. Take a look. So we get 2 and 2. Now, what if you want to increment x by more than 1? Let's say by 2. Well, there are 2 ways to do this. Let's remove y. We don't really need it anymore. We can write x equals x plus 2. So first, we add 2 to x. The result would be 3, and then 3 will be copied into x. The other way is to use the augmented or compound assignment operator. So we can write x plus equals 2. What we have on line 8 is exactly identical to what we have on line 7. But as you can see, it's shorter. So This is a better way to write the same code. Now, this is one of the augmented assignment operators. We have the augmented assignment operator for other arithmetic operators. So we can type x minus equals 2, and this would reduce the value of x by 2. We also have multiply and divide. So these are the augmented or compound assignment operators. Here we have declared this variable x equals to 10 plus 3 times 2. What do you think is the result of this expression? The result is 16. Let's run this program and find out. So run, there you go. We got 16. But why? Well, this is a very basic math concept that unfortunately a lot of people don't know. In math, the multiplication and division operators have a higher priority, so they get applied first. In this example, this expression 3 times 2 is evaluated first. The result is 6, and then 6 is added to 10. That's why we get 16. Now, if you want to change the order of these operators, you can always use parentheses. For example, if you want this expression to be evaluated first, we wrap it in parentheses. So, like this. Now, Java compiler will first evaluate this expression. The result will be 13, and then 13 is multiplied by 2. So we get 26. Take a look. There you go. So be aware of the order of these operations. Parentheses always have the highest priority. Then we have multiplication and division. And finally, we have addition and subtraction. About casting and type conversion. So I'm going to declare a short variable called x and set it to 1. And then I'm going to declare an integer called y and set it to x plus 2. In this example, we're adding a short to an integer. What do you think the result is going to be? Well, let's take a look. So SOUT, let's print y, we get 3. That is what you were expecting. But let me explain what happens under the hood for this expression to get executed. Because we're dealing with two different types of values, one is a short, the other is an integer, one of these values should be converted to the other type so they are equal. Now I got a question for you. How many bytes do we have in a short variable? We have 2 bytes. How many bytes do we have in an integer? 4 bytes. So any values that we store in a short variable can also be stored in an integer variable, right? So when this piece of code is going to get executed, this is what's going to happen. First, Java looks at the value in this variable. It's 1, right? It's going to allocate another variable, an anonymous variable somewhere in memory. We don't know where that is. We don't know the name of that variable. It doesn't have a name. It's anonymous. That variable is going to be an integer. Then Java is going to copy the value of x into that memory space, and then it will add these two numbers together. This is what we call implicit casting. Let me type it here. Implicit casting. That means automatic casting or automatic conversion. We don't have to worry about it. Whenever we have a value and that value can be converted to a data type that is bigger, casting or conversion happens implicitly or automatically. So byte can be automatically converted to short, and this can be converted to int and long, okay? Now, what about floating point numbers? Let's look at an example. I'm going to change this to a double 1.1. Now here we have a compilation error because on the right side of the assignment operator, we have a floating point number, a double. On the left side, we have an integer. So we need to change this to double. Now, when we execute this code, we're going to get 3.1. Let's verify this. There you go. Now let's see how casting happens here. In this case, we're dealing with a double and an integer. An integer is less precise than a double because in a double, we can have digits after the decimal point. So in this example, Java is going to automatically cast this integer to a double. So that will be 2.0. And then 2.0 will be added to 1.1. Okay, so back to this chain. Here we're going to have float and then double. So as a general rule of thumb, implicit casting happens whenever we're not going to lose data. There is no chance for data loss. Now, what if we want y to be an integer? So in this example, we don't care about the digits after the decimal point. We want to see 3 on the terminal. How should we do this? This is where we should explicitly cast the result. So we should cast x to an integer like this. parentheses, int. This is explicit casting. We convert x to an integer, so the result will be 1 without a decimal point. 1 will be added to 2, and y will be 3. Take a look. There you go. So this is all about implicit and explicit casting. Now, this explicit casting can only happen between compatible types. So all these types are compatible because they're all numbers. But we cannot cast a string to a number. In other words, if x was a string, like this, let's say 1, we cannot cast x to an integer because they are not compatible. So how do we do this? Well, for all these primitive types you have learned, we have wrapper classes. So in Java, we have a class, which is a reference type called integer. This class is defined in java.lang package. And in this class, we have a method called parseInt. So this method takes a string and returns an integer. So integer is the wrapper class for the int primitive type. We also have short, and in this class we have parseShort. So it takes a string and returns a short. Similarly, we have float and double, and obviously the name of these methods are different. So here we have parseFloat. So back to this example, let's say we get x as a string and we want to convert it to an integer. This is how we do it. Integer dot parseInt. We pass x here and then add it to 2. Take a look. So we get 3. Now you might be curious why this matters. Why should we parse or convert a string to a number to add it to something else? Well, pretty much in most frameworks for building user interfaces, whether you're building a desktop or a mobile application or a web application, we always receive input from the user as a string. So if you have a form with a bunch of text boxes or drop-down list, almost always we get values as strings. So that's why we need to convert these strings to their numeric representation. Okay? Now, what if x is a floating point number here? What will happen when we try to parse this as an integer? Let's take a look. Once again, we get an exception, which is how Java reports errors to our programs. We're going to talk about exceptions in detail in the future. So if the user enters 1.1, we cannot use this method. Instead, we should use float or double. Let's say double because that's easier. Double parse double. So we parse this number as a double, add 2 to it, and then store the result in a double. And then we will get 3.1. Beautiful. Next, we're going to look at the math class for performing mathematical operations. Math class for performing mathematical operations. So in Java, we have this math class that is defined in java.lang package. So it's always there. We don't need to explicitly import it. Now, this class has a number of useful methods. The first method I'm going to show you is the round method. And with this, we can round a floating point number to a whole number. So as you can see, this method is overloaded, which means it's implemented twice. In the first implementation, it takes a float and returns an int. In the second implementation, it takes a double and returns a long. So let's pass 1.1 as a float to this method and store the result in an integer, like this. Now we print the result and we get 1. Beautiful. Another useful method is ceil or ceiling, which returns the smallest integer that is greater than or equal to this number. So the ceiling of 1.1 is 2. Now here we have a compilation error because this method returns a double, but we're storing the result in an integer. So here we need to explicitly cast this to an integer. And now you can see the ceiling of this number is 2. We have another useful method that is floor. So the floor of a number is the largest integer that is smaller or equal to this number. In this case, it's going to be 1. Let's take a look. There you go. Another useful method is max, which returns the greater of 2 values. And once again, this method is overloaded. So in the first implementation, we get 2 integers. We have other implementations for longs, floats, and doubles. So let's pass 2 integers here, 1 and 2. This will return the greater number, which is 2. There you go. Similar to this, we have min, That's pretty straightforward. Another useful method is random for generating a random value between 0 and 1. Once again, we get a compilation error because this method returns a double. So let's change that to double. Now, every time we run this program, we get a different number. And this number is a floating point number between 0 to 1. Now, what if we want a number between 0 to, let's say, 100 instead of 0 to 1? Well, we simply multiply this by 100. Take a look. So every time we run this, we get a different number between 0 to 100. Now, if we don't want these digits after the decimal point, we can either round this number or cast it to an integer. Let me show you. So we can call math.round and pass the result of this expression. So I'm going to cut this, add parentheses to call the round method, and then paste that expression. Now let's run this code. So every time we get a double, we still have the fraction here. So we can change the type to an int. Now we have a compilation error because the round method returns a long, but here we have declared an integer. This is one of those cases where implicit casting cannot happen because we have a value that is represented in 8 bytes of memory, and we want to store that in a variable that has only 4 bytes of memory. So implicit casting doesn't work, but we can use explicit casting because we know the result of this expression is a number between 0 to 100. So we can definitely store it in an integer. So let's add int here. Now let's run this again. There you go. Now, what if we don't use the round method here? Let's see what happens. So I'm going to remove the call to the round method and simply apply this casting over here. Let's see what we get. Now, every time we run this program, we get 0. Do you know why? Because here we're applying this casting to the result of this method call, not this entire expression. As you saw earlier, every time we call the random method, it generates a number between 0 to 1. So when we cast that number to an integer, we'll lose the fraction. We always get 0, and 0 times 100 is 0. To solve this problem, we need to wrap this entire expression in parentheses. So we add parentheses around this. And now, when we run this, we get an integer between 0 and 100. Numbers, we need to format them as currency values. For example, we might have a number like this. Imagine this is the price of a product. To display this to the user, you want to add a $sign here and separate every 3 digits with a comma. Or we might have a number like 0.1, and we want to represent this as a percentage value. So instead of 0.1, we want to display 10%. So in this tutorial, I'm going to show you how to format numbers in Java. We have this class number format that is defined in java.text package. In this package, we have a lot of classes for handling text, dates, numbers, and so on. So let's press enter here. It's imported on the top. Beautiful. Now we want to declare a variable. So let's give this variable a name, currency. Now we need to instantiate this. So new number format. However, we get a compilation error here. Let's take a look. Number format is abstract. It cannot be instantiated. So in Java, we have this concept of abstract classes. So some classes are abstract and they're basically like a half-baked cake. We cannot use the new operator to create an instance of them. We're going to talk about abstract classes and why they exist later in the course. For now, remember that we cannot create an instance of the number format class because it's abstract. So there is another way. Let me show you. This class has a bunch of methods that start with get. So we have get currency instance. And when we call this method, this will create an instance of the number format class and return it. So instead of using the new operator, we're going to use this method here. This is what we call a factory method because it's like a factory. It creates new objects. Now look at the return type of this method. It's a number format object. Okay. So we call this method. Now we get the return value and store it in a variable of type number format called currency. Okay. Let me temporarily zoom out so you can see all the code. There you go. So on the right side of the assignment operator, we're calling the get currency instance method. We get the result, which is a number format object, and store it in this variable. Okay. Now I'm going to zoom in so you can see clearly. All right, that's better. Now, this object has a method for formatting values. Once again, you can see this method is overloaded. We have multiple implementations. We can give it a long or a double or whatever. So I'm going to call this method and pass a value like 1, 2, 3, 4, 5, 6, 7.891. So we have 3 digits after decimal and a few other digits here. Now this method will return a string representation of this number formatted as a currency. So let's get that and store it in a string variable like result. And then we're going to print result on the terminal. See what we get. So we get this $sign. Every 3 digits are separated using a comma, and we only have 2 digits after decimal point. So this class is very handy in formatting numbers as currencies. We have another method for formatting a number as a percent, and that is get percent instance, right? Now it returns an instance of the number format class specialized for formatting numbers as a percent. So we need to rename this variable from currency to percent. Now we don't want to manually change this because there are multiple references to this variable. This other reference was not updated. So let me show you the proper way to rename objects in IntelliJ. If you right click here, you can see this refactor menu. And here we have rename. Now look at the shortcut on the right side. Unfortunately, it's not visible in my recording window, but on Mac it's Shift and F6. I always use shortcuts because they're faster. So let's press Shift and F6. Now we get this red box, and below this we can see a few suggestions for a better name. We can choose one of these or pick our own name. I'm going to change this to percent. And note that as I'm typing this, the other reference gets updated automatically. So this is very helpful. Now let's press enter. Okay, we're done with renaming. Now let's pass a different value here. So let's say we have a number like 0.1. We want to format this as a percent. Let's run the program. There you go, we get 10%. Beautiful. Now let me show you a cool technique. In this program, we don't really need this percent object because we have used it in a single place. It would make sense to have this as a separate variable if we have multiple references to it. So what can we do here? We can completely get rid of this object. So let's delete this piece of code. We're basically calling this method of the number format class. As you know, this method returns a number format object. So right after calling this method and before the semicolon, we can use the dot operator to access the methods or members of the number format object. So here we call the format method straight away and pass our value. This is what we call method chaining. We're chaining multiple methods together. So here's one method and here's another method. Now this returns a string, so we can store it in this result variable. Let me cut this expression from here and put it over here. Now we have double semicolons, so I'm going to delete one of them. All right, beautiful. How to read input from the user. In Java, we have this scanner class that is defined in java.util package. Let's import this and create a scanner object. So new scanner. Now here inside this parenthesis, we need to specify where we're going to read data from. Are we going to read it from the terminal window? Are we going to read it from a file or what? To work with the terminal window, we type system.in. This is one of the fields in the system class. A field, as I told you before, is like a variable that we define in a class. So we have system.in. We also have system.out, which we use to print something on the terminal, right? Now, let's use system.in and terminate this statement with a semicolon. Now, this object has a bunch of methods for reading data, and all these methods start with next. So we have next byte for reading a byte. We have next line for reading a line. We have next boolean for reading a boolean, and so on. So let's call the next byte method and see what we get. This returns a byte value, so we can store it in a byte variable. Let's say someone's age. And then we print it on a terminal saying you are plus age. So here we're concatenating a string with a byte. And in this scenario, we're going to have implicit casting or implicit type conversion. So Java will automatically convert this byte variable here to a string so they can be added together. Okay. Now let's run this program and see what happens. So here in the terminal window, we can type 20, enter, and it says you're 20. Beautiful. But this is pretty boring. Let's add a label here and ask the user to type something. For example, before reading data, we're going to call the print line method and say age : Now let's run the program. So we get this label here. However, whatever we type will appear on the next line. This is because the print line method adds a new line after this label. To solve this issue, we call the print method. Now let's run the program one more time. We get this pop-up box because our program hasn't finished execution. So we need to tell IntelliJ that we want to stop and rerun this program. All right. Now, whatever we type appears right in front of this label. Beautiful. Enter, we are 20. Now, what if we type a floating point number like 20.1? We get an exception because this method can only parse byte values. If you want to get a floating point number, we need to call next float or next double. What if you want to read a string? We don't have next string. We have next and next line. Let's look at the differences. So first, I'm going to call the next method. Here we have a compilation issue because this method returns a string. I'm going to change this to a string. Let me collapse this. That's better. We should also rename this variable. So what was the shortcut? Shift and F6. Now let's rename this to name. Enter. Beautiful. And one last time, we should also update the label. Name. Run the program. So I'm going to type my name here, Mosh. It says you're a Mosh. Beautiful. One more time. This time I'm going to type my full name, Mosh Hamedani. But we don't get the last name. Here's the reason. These words that we have here, these are called tokens. Every time we call the next method, it reads one token. So here we have a space, we have two tokens, and we need to call the next method 2 times to get the full name. The first time we call it, it returns Mosh. The second time we call it, it returns Hamedani. Then we need to combine these two together. This is not ideal. So that's when we use the next line method. With this method, we get the entire line that the user enters, no matter how many spaces or tabs are there. Take a look. So Mosh Hamedani, and we get the full name. Now, what if I type a few spaces before my name? Let's see what happens. So those spaces also appear here, and this looks a little bit odd. This is where we use the trim method. Remember, with trim, we can get rid of all these white spaces before or after a string. So this next line method returns a string that we are storing in this variable, right? Now, just before storing the result in this variable, here we can use the dot operator to access the members of this string object. So we call the trim method and then store the result in this variable. Once again, we're chaining multiple methods here. Let's run the program. So a few spaces, Mosh Hamedani, and we get this beautiful output. I want you to use what you have learned in this section and build a mortgage calculator like this. So when we run this program, we get a few questions. The first question is the principal or the amount of loan we want to get. Let's say $100,000. The second question is the annual interest rate. Let's say 3.92%. And the third question is period in years. Let's say we want to get a loan for 30 years. So this program calculates our monthly payments and displays it as a currency. This is a great exercise for you to practice all the materials you learned in this section. Now, before you get started, I want to give you a few hints. Here's a formula for calculating the mortgage or the monthly payments. I found this page on wikihow.com. It's called Calculate Mortgage Payments. So let's see how this works. Mortgage equals P or principal or the amount we're going to loan multiplied by R, which is our monthly interest rate. This is very important. So this number that we get here is our annual interest rate. We need to divide this by 12. Also, take into account that this number is represented as a percent. To calculate the actual interest rate, you need to divide this number by 100. So in this example, the interest rate is 0.0392. So whatever the user enters, divide it by 100 and then divide it by 12 to get to the monthly interest rate. Now we have this monthly interest rate. We need to multiply this by this expression. Here we need to add 1 to this interest rate and raise it to the power of n, where n is the number of payments. So we need to multiply this number by 12 or 12 months to calculate the number of payments. Now, to raise this number to the power of n, you need to use the POW method of the math class. So this math class has this POW or power method that takes two arguments or two values, a and b. So go ahead and spend 10 to 15 minutes on this exercise. When you're done, come back, see my solution. And by the way, don't worry if your code is different from mine. We all think and code differently, so it's perfectly fine if your code is different. Just look at my code, see what I've done here, and see if there are ways you can improve your code. That's what matters, okay? So here in our main method, first I have declared two final variables or constants. The first one is month in year, which I've set to 12, and the second one is percent, which I've set to 100. The reason I declared this constants is that I didn't want to have magic numbers in this code. So over here, where we calculate the monthly interest, we get the annual interest and divide it by percent and then months in year. This code is very self-explanatory. Someone else reading this code will have no problem understanding what's going on here. In contrast, if you had a magic number here, like divide by 12 and then 4, whatever, someone else reading this code would wonder, what is this 4 doing here? What is 12? Now, it's quite obvious to you that 12 is the number of months in a year, but trust me, sometimes other people cannot see this straight away. So, as a best practice, avoid magic numbers in your code. Always use constants or final variables to describe them. So let's revert this back. All right. So after declaring this constants, I have created this scanner object. Here we ask the first question, principal, and we read the answer as an integer. I thought integer is a good data type for storing the principal. Because short is not enough, with short we can store a maximum of $32,000. That's not enough. What if someone wants to finance $1 million? So int is good, and it allows us to store a value up to 2 billion. Next, we ask the second question, annual interest rate. We read this as a float. Here I could use double, but the interest rate is a small number, so float is sufficient for that. We don't really need double. So we get the annual interest, and then based on that, we calculate the monthly interest. Also, see how I have named my variables? All variables have a proper, meaningful names. There are no magic words here like MI as in short for monthly interest or M1 or M2. Do not use magic names for your variables. Always use meaningful and descriptive names. All right. Next, we get the period. We read this as a byte because the maximum number we want to support is 30. So 1 byte is sufficient to store the number 30 or anything smaller. Now, based on the number of years, we calculate the number of payments. Note the camel notation here. I've capitalized the first letter of every word except the first word. So we get years and multiply it by months in year. Again, the code is very self-explanatory. Once we collect all this data, then we calculate the mortgage. So we get the principal multiplied by this expression and then divided by this other expression. Let's have a quick look here. Now, this looks a little bit complicated. So if you want to download my source code, look below this video. I've attached it for you to download. And finally, after we calculate the mortgage, we use the number format class to format this value as a currency. So we get the result, store it in this string, mortgage formatted, and print it over here. Now here we could also avoid declaring this variable and simply add this expression over here. But I decided to do this to increase the readability of this code. Otherwise, this line would be so long. But that's just my personal preference. You don't have to follow this. All right, so this was my implementation of the mortgage calculator. However, this program has a number of problems. The first problem is input validation. So if you run this and enter a non-numeric value like XYZ, our program crashes. Or as another example, if we enter a negative value here, our program is not going to behave properly. So that's where conditional statements come to the rescue. In the next section, we're going to talk about conditional statements. You will learn how to use these statements to validate the values entered by the user. So that brings us to the end of this section. I hope you learned a lot and thank you for watching. About variables and constants, you learn about primitive and reference types. You learn that primitive types store simple values, but reference types hold references to complex objects. That's why we call them reference types. You also learn about casting and type conversion. You learn about two types of casting, implicit and explicit. You learn how to work with numbers, strings, and arrays. And finally, you learn how to read input from the terminal. I hope you learned a lot and been enjoying the course so far. In the next section, we're going to look at conditional statements for controlling the flow of our programs. So I will see you in the next section.